Welcome back. In this video I'll be solving Leetcode problem 1769, minimum number of operations to move all balls to each box. So we are given n boxes, binary string boxes of length n. 0 doesn't have a ball, and 1 if it contains one ball. Okay, some boxes can have one or more balls after that operation. Okay, so the solution that's off n squared is pretty simple, but that's not sufficient, I suppose. So I think I got an idea for off n solution, time complexity wise. So we need to take total. That will be equal to, or I'll do it like this. First we build nums, which is int of I for I in boxes, so we don't have hard time with this string. And we need total sum, or total will be just the sum of nums. And what's the idea? So we figure out what's the cost of, what's the minimum number of operations to transfer all balls to the 0th place. And then when we know that, from that on we can just track how many balls were before ith index and how many are after, and with that information we can update the cost for doing this. So I'm not sure if it makes sense, but let's do it. So cost is equal to I'll do it like this, so count times value for count value in enumerate nums. This will just multiply the index with the value, so that's essentially the cost for moving all the balls to the 0th box. And now that we have that information, let's answer and then the cost. Now that we have this information, we have to track, so let's have pre and post. So pre will be all before is currently 0, but since we added this one, it will be nums of I, nums of 0, and post is equal to nums, or actually this is even better, nums of 0. So this is like setting up the case. So total minus nums of 0 is what's post in this first case, and we have the cost. So what do we need to do? So for I in range 1 till length of nums. So what happens at the next index? So at the next index we have prefixes increased by nums of I minus 1. Postfix is decreased by post is decreased by nums of I and cost is equal to previous cost but increased by the pre-number, because whatever was previously at the previous place we have to transfer it to one more place, but decreased by nums of I because those are at the right place, and also decreased by whatever is later and doesn't have to move one more place. So essentially, is it post or what do I think about it? Should be post, yeah. So new cost is previous cost plus new ones that we skipped minus these that are at the same place and minus all that are to the right that we don't have to move now on. Okay, I think that's it. So and cost, so something like this should work and seems good. Let's maybe remove these I don't need to actually store this, so yeah, let's have it. Because of this enumeration, let's run this. And this works. Maybe we can optimize a bit with the space, but yeah. What did I do here? This was stupid, so yeah, same more or less, but yeah, this is the idea for this problem. Let's just check the time and space complexity, but I already decided, so time complexity is off, because we just do the sums and one for loop later. Complexity also fan because we have those lists. So yeah, if you have any questions, feel free to leave them in comments. That's all that I have for today, and yeah, thank you for following in this one, and see you in the next one.